Okay, today we're going to be going over how to complete mass-to-mass problems. We've already gone over how to map them out. Now we're going to go over how to solve them. Okay, so the two skills you need for this, you need to be able to convert between moles and grams. And the second skill is you need to be able to use mole ratios to convert from moles to moles. So we've done both of those things. We're just going to combine them. Okay, just go ahead and go through our first problem. So our first problem, it's asking us, these are also, we've mapped these out before, so you should be familiar with them. How many grams of an H3 are produced from 40 grams of H2? Okay. In other words, if we have 40 grams of this, we're trying to figure out how much of this can we make. So that's a common question that scientists ask, right? We have a certain amount of substance, and we want to figure out how much of this would be made. Okay. So remember, we can't go from grams to grams. We have to take this pathway. We're here right now, we're at grams, and we have to take this entire pathway to get to here. Okay? In other words, I'm going from grams of H2 to moles of H2. Then I'm going to go from moles of NH3 finally to what I want, which is grams of NH3. Okay, so we're gonna go ahead and go through this and go through the steps on how to solve this. Okay. All right. Step one, we go ahead and we write what we were initially given, which was 40 grams. So we have 40 grams of H2. We want to turn that into moles. That's our first step. So we go times grams in the bottom, 1 mole on top. Okay, then we put the molar mass of H2. Well, the molar mass of H2 hydrogen, if we round it, is 1, and we have 2 of them, so it'd be 1 times 2. The molar mass will be 2. 40 divided by 2 is going to give us 20 moles of, got this here, 20 moles of H2. Okay. So that's our first step. Okay. Now let's go ahead and go on to the next step. So now we're going from moles to moles. Remember, whenever we go from moles to moles, we have to use the equation, which we've done this before, right? So we go times. Well, I want to get rid of this, so that goes in the bottom. Moles of H2. I want moles of NH3, so I put that on top. Moles of NH3. Then I have to figure out where do these numbers come from. Well, my equation tells me that for every 3 moles, I get 2 moles. So for every 3 moles, I get 2 moles. Then I just do the math. That gives me, these cancel. 20 times 2 is 40. 40 divided by 3. It's going to give us, I'm going to put that into my calculator. And for these, you can just round to the first decimal. So we'll go 40 divided by 3 gives us 13.3 repeating. This is going to equal 13.3. Okay, moles of NH3. So we just need one more conversion. So we're here and we need one more conversion to turn that into grams, which we've done before. Okay, so I'm going to go ahead and I'm going to rewrite this here. So I'm going to rewrite that. That's going to give me, so I go 13.3 moles of NH3. So just rewrote that. Now we have to turn it into grams, but we've done this before, right? We go moles of NH3 in the bottom, grams on top. We always use 1 mole. That's what the periodic table tells us, the mass of 1 mole. So I have 1 nitrogen, which nitrogen is 14 grams. And I have 3 hydrogens, which are each 1. So 1 times 3 will give me 3 grams plus 14 grams will give me 17 grams. I multiply that 3.3 times 17 gives me my final answer, which will be 226.66 if I round to the first decimal, 0.7 grams of NH3. And that would be my final answer. So these problems are a little bit difficult because there's a lot of steps involved in them. It's not just one step, it's 3 steps for all of these problems. Okay, let's go ahead and go through another example. Okay, now we're moving on to the next problem. So I'm not going to map this one out, I'm just going to go ahead and solve it. So we have 80 grams of H2, and we're trying to figure out how many grams of N2 are being made. In other words, we have 80 grams of H2, we don't know how much N2 is being made. Alright, so step 1, we're turning these grams into moles. That's step 1. So we take the 80 grams and we're going to turn that into moles. So we have 80 grams of H2 times, well, grams go on the bottom because that's what we want to get rid of. Moles of H2 is what we want, so we put that on top. Okay, we've already figured out that the mass of H2 is 2 grams. 1 mole equals 2 grams. That's going to give us 80 divided by 2. These units cancel. We're left with 40 moles of H2. Okay, so that's just basic stoichiometry. We took this and we converted it into moles. So we've done that before. Okay, so now I'm going to write the next. I'm just going to rewrite this and I'm going to do the next step down here. So then we're going to take these 40 moles of H2 and we're going to convert it into moles of what we want, which is N2. So we go moles of H2 in the bottom, moles of N2 on the top. Okay, well, we got to figure out the numbers now. That's where we look at my equation. My equation tells me for every 3 of these, I get 1 of these because there's an invisible 1 there, right? So for every 3 hydrogens, I get 1 nitrogen. Okay, that gives me 40 divided by 3, 40 divided by 3 will give me 13.3. These cancel. That's what I'm left over. Moles of N2. Okay, we're almost there. We want to figure out the grams, so we just got to turn this into grams. So I'm going to take this. I'm going to rewrite it down here. So this is the same thing I did in the first problem. I'm just doing it step by step and rewriting a few things. Okay. All right. Now I go times 1 mole in the bottom. Well, let's just go units first. Moles of N2 in the bottom. Grams on top. Whenever I'm going from moles to grams, I always use 1 mole because that's what the periodic table tells me. So N2. Well, nitrogen has a mass of 14. I have 2 of them. So that gives me a mass of 28 grams. I multiply 13 times 28 will give me, actually let's be more accurate, 13.3 times 28, it's going to give me 372.4 grams of N2. In other words, if I have 80 grams of H2, I need this many grams of N2 in order for that reaction to react together. Okay, in order for those reactants to react in the correct proportions. So it's just 3 steps. It's grams to moles, and then moles to moles, and then moles to grams, which we've done. Okay, let's work through one more problem. Actually, we might do 2. Okay, so in this problem, let's see what they're asking us. Question is, how many grams of oxygen, so oxygen, remember that oxygen's O2, are produced by the decomposition of 100 grams of potassium chlorate, which is this compound right here. Okay, so in other words, I have 100 grams of this, and I want to figure out, well, how much oxygen does that make? Okay, well, let's go ahead and go through the process. Remember, we have to go grams to moles of KClO3. Then I can go to moles of oxygen. Then I can go to grams of oxygen. So I have to take this path. I can't just go grams to grams. Okay. All right. Step 1. I have 100 grams of KClO3 times a fraction. Grams go in the bottom. Moles go on top. Right? I use 1 mole of KClO3. So I'm not going to go over how to find the molar mass for that, because we should be able to find molar mass. But essentially we would add those all up, right? So what I'm going to do is I'm just going to do a quick Google search to give me that molar mass. Okay, so if I Google search that molar mass is going to be, you can't really see it, but that molar mass is going to be 122.5. Which we could have rounded to 123. Okay, we do the math. 100 divided by that. 100 divided by 122.5 is going to give me 0.816 moles of KClO3. Okay. All right. Now we have to turn that into moles. So I'm going to bring this down here. 0.816 moles of KClO3 times moles of KClO3 in the bottom, because that's what I want to get rid of. Well, what do I want? Well, I'm looking for oxygen, right? So moles of oxygen go on top. Now we have to look at the equation. For every 2 moles of this, I get 3 moles of that. So for every 2 moles, I get 3 moles. Okay? So then I have to multiply that. I have this times 3 divided by the bottom, which is 2, gives me, let's round to the first decimal, 1.2 moles of oxygen. Last step, all we got to do is we got to take this, turn this into grams. So I have 1.2 moles of O2 times moles in the bottom, grams on top, because that's what I want. 1 mole of O2 equals, well, oxygen has a mass of 16. 16 times 2 gives me a mass of 32. I went times 2 because I have 2 oxygen. Okay? I multiply 1.2 times 32. Gives me a mass of 39.18 grams. Okay, in other words, if I have 100 grams of this substance, I will make about 39 grams of this substance. Okay. You can also do these problems all in one single step, but I'm just showing you the methods, the step-by-step method. Okay. And I'll put a video up there that's going to go over how to do all of this in one step. So if you want to look at that, you can look at that.